last night, which is what happens after a week of telling you that I'm too tired to do this. So I'm going to look at the problem in a second. And the other thing is that thanks to some of you for your feedback, I made a couple big changes to my encode computer. One is that I commented out all the logging statements. I was thinking that, if I set the log level higher than debug, it would be really cheap and would just skip over them. And it's mostly true. I mean, they don't take much time. They take a little bit of time. But because I was using these F strings here, it was actually um, doing all this work to create the F string, which means it was like making all these expensive string interpolations like millions of times and then throwing them away. So that's why you should not use F strings for logging. It turns out Pilot will warn you about that. Anyway, once I commented them all out, it went really faster. The other thing someone suggested was that instead of the way I was handling the input, I should give the encode computer an input function that it can call whenever it needs input. So it passes this get input, and now when I get the opcode, which is store input, it calls that function and takes the input. And then, so for instance, in the breakout game, what I do is I make this get input function that when you ask it, what input do you want, you look at the ball and paddle and return the direction. And otherwise, you're not feeding it inputs. That's better than throwing it away. And finally, the last thing I did was I renamed I didn't like having computer call, the underscore call. So I just renamed it to go. So the encode computer is faster now and a little bit cleaner. So if I have to use it again, hopefully it will work. It will work better. So let's look at problem 14, and hopefully it's not too bad. Stoichiometry. As you approach the rings of Saturn, your ship's low fuel indicator turns on. There's any fuel here, but the rings have plenty of raw material. Perhaps your ship's interstellar refinery and brand nanofactory turns these raw materials into fuel. Yes, nanofactory produces a list of the reactions can perform that are relevant to this process. Each reaction turns some quantities of specific input chemicals into some quantity of output chemical. Almost every chemical is produced by one reaction. The only exception, ore, is the raw material input in the entire process. Okay, this is already saying directed to the second graph. You just need to know how much ore you'll need to collect before you can produce 1 unit of fuel. Each reaction gives specific quantities for its inputs and outputs. Reactions cannot be partially run, so only whole integer multiples of these quantities can be used. It's okay to have leftover chemicals. For instance, 1A, 1B, 1C means exactly 2 units of chemical D can be produced by consuming exactly 1A, 2B, and 3C. You can run the full reaction as many times as necessary. For example, you produce 10 blah, blah, blah. Suppose your nanofactory produces the following list of reactions. First 2 reactions use only ore as inputs to indicate you can produce as much chemical A as you want. Increments of 10 units and as much chemical B as you want, each costing 1 ore. To produce 1 fuel, a total of 31 ore is required. 1 ore to produce 1 B, and then 30 more ore to produce 7 plus 7 plus 7 plus 7 equals 28A. Required in the reactions to convert the B to C, C into D, D into E, and finally E into fuel. 38 is produced in this reaction requires this great increments of 10. Or suppose you have the following list of reactions. The above reactions requires 165 ore to produce 1 fuel. Consume 45 ore to produce 10A. Consume 64 ore to produce 24B. Consume 56 ore to produce 40C. Consume 6A, 8B to produce 2AB, blah, blah, blah. Consume 16C4A to produce 4CA. Consume this to produce 1 fuel. Here's some larger examples. Given the list of reactions in your puzzle input, what is the minimum of ore required to produce exactly 1 fuel? Okay, so let's copy this first. And I have some ideas in my head that may or may not work, but I will tell you that my first reaction is that we want to use some sort of priority queue, and I don't use priority queues very often, so I need to look up exactly how it works, and I think it's a minimum queue. Pop returns the smallest item. Heap 0 is the smallest, heap dot sort. Okay, so we'll use heap q, I think. And then finally, we need to parse one of these rules. So let's go back and get one of them and say that a rule looks like this. And actually, let me get a rule that actually looks like that. And so, def parse rule raw, which is a string, and that's going to return a rule. And so from typing import named tuple, class rule, which is a named tuple, and I don't know what I want there yet, so I'll pass. So I'm switching back to my Linux machine from my MacBook, which means I keep hitting the exact wrong control key, which is going to cause a lot of grief. And so let's say left-hand side, right-hand side equals raw dot split on this, okay? And let's say inputs equals left-hand side dot split on comma space. And so let's say inputs is going to be a dict from string to int, and actually let's just say I don't think I need, well, dict is fine, that doesn't matter. And let's say output equals is it only going to ever produce one thing? Yes, it looks like it is. So output, so let me see, pair equals tuple. What do I want to call this? Chemical. I'll call it a chemical. So, no. Let me class amount named tuple equals chemical, which is a string, and my naming here is not good, but a class rule inputs is going to be a list amount, and output is going to be an amount. So, and so inputs equals, or let's say input amount equals amount and let's say static method from string raw string goes to amount, and I will just do it this way. Let's say chemical quantity equals raw dot strip dot split, and return amount chemical int quantity. Input amounts equals amount from string input for input in inputs, and output amount equals amount from string right hand side, and return rule input amounts output amounts. And then we want to assert that parse rule this equals rule of inputs equals amount A7, and I think I might have this backwards. So let me just do it like this, and quantity chemical. Actually, no. What I need to do is this. quantity, comma, chemical amount A7 amount D1 and then amount E1. Okay, so let's cd day 14 python day 14.py run day 14.py name list is not defined. Not enough values to unpack. Because it's that kind of thing. Okay, so that worked. So that's good. So let's take their example now and let's say raw equals this, and let's say rules equals parse rule raw for raw in raw dot split. So let's not enough. Right, so I need to split on new lines. Let's try this again. And now if I look at my rules, I say 7A plus 1D goes to E, goes to 1 fuel. Okay. And now what I want to do is I want to say, consume 45 ore, consume 64 ore to produce 24B, consume 56 ore to produce 40C, consume 6A, 8B to produce 40C, blah, blah, blah. Here's some larger examples, 1322 ore for 1 fuel, and so, so let's think about how to do this efficiently. So basically, what I want to do is I want to let me think about this for a minute. I think the way I was approaching it is probably not great. So what I want to do is I probably want to work backwards. And do I want to work backwards? Let's see how many times fuel appears here. So fuel appears once. So, if I were to start here and say 1 fuel, then I want to turn 1 fuel into these guys. Then I can turn these guys into Um, so let me look at this one because this one's a little bit more interesting. So I take fuel. Does every guy appear only on the right-hand side once? If every guy appears on the right-hand side only once, um, len rule dot output dot chemical for rule and rules. Okay, and let me with open d14.text as f raw equals f dot read, and then rules equals parse rule line for line in raw dot split dash n. And so let me run this again. Then rules. No, this should have been lowercase raw. So every guy only appears on the right-hand side of one rule. So that makes things um, a little bit simpler in that I can kind of work backwards and say, um, given the fuel, what do I need? And basically, so like let's think about it this way. One fuel turns into 7A and 1E. 1E turns into this 14A and 14 whatever. So all we need to do is basically work backwards. So def least or rules, which is a list of rule. And so, and let me say rules by product equals rule dot output dot chemical rule for rule and rules. And let's say inventory equals fuel 1. Okay. And so now what I want to do is I want to say, in order to get fuel, I need to get these guys. And I'll just work backwards and say while or not in inventory, or let me call this requirements. One, while or is not in requirements. Can I pop out of a dictionary? Let's see. While or is not in requirements, let's say next x dot, I can't do that, can I? Next iter x dot keys equals next iter x dot keys. And quantity equals requirements key. And so that's the quantity I want. And let's say rule equal rules by product key. So I find the rule for that, and let's say I need 5, but the rule produces 3, then I need to run the rule twice. So, math.ceal 5/3, math.ceal 6/3, 7/3. Okay, so let's import math. And so num times equals math.ceal rule dot output dot quantity divided by, actually no, it's quantity needed key, okay, next iter, let me say chem for chem quantity in requirements.items if quantity is bigger than 0. So I'm worried that we'll end up with some like negative requirements, and we don't want to pick those. So we'll pick something that we need more than one of. So we do num times, and for amount in rule dot input, what did I call it? Rule dot inputs, requirements amount dot chemical equals requirements dot get amount dot chemical 0 plus num times amount dot quantity, and so I add that, and then I keep going, and then I just want to return requirements dot or, and so now I have this rules. So let's see what happens if I do it against my small sets. Probably won't work, but dict object is not callable. Ceal takes exactly 1 argument because I want to divide. I need to run it again. And what I need to do is I need to subtract it off from my requirements. So requirements key minus equal num times rule dot output dot quantity. So I could end up with like negative, so that like I've got extra, so that way if I have more, it will work. Requirements 10. So is that right? First two requirements only use ore as inputs to indicate you can produce so much chemical A. So in fuel, a total of 31 ores required. One ore to produce 1B, and then 30 more ore to produce, because I need to require all of them, basically. And so, um, while not done, and let's say we're done, we'll, return fuel in requirements, and every quantity for chem quantity in requirements dot items is less than or equal to 0 if chem is not equal to or. So in other words, actually, I don't think well, I think that's fine. So let me try that. Less than or equal to not supported between instances of dict item, all quantity less than or equal to 0. Got that wrong. Key error or quantity is bigger than 0 and chem is not equal to or, because we don't want to actually, let me just change this, and let's say or needed equals 0. And so I'm going to return this. All quantity is bigger than 0 for quantity in requirements.values. So there's nothing that I need any of. And so now I won't even bother with the or. And for amount in rule.inputs, if amount dot chemical equals or plus equals amount dot quantity times num times. Otherwise, I'll add to my requirements, and now I just want to return or needed. So I'll just keep it separately, which may be a bad idea, but so let's run it again, and now it says 31, and I think that was the right answer actually, wasn't it? So let's try raw2 equals this, print least or of parse rule line for line in raw2 dot split dash n. One, 3, 3, 1, 2, and that is right. So so now I'm just going to what did I call this? I called this lowercase rules. So I'm just going to print least or of lowercase rules and run this. and it says 654.909. So I back to the Linux machine, copy, um, and put this here, and that's the right answer. Continue to part 2. After collecting ore for a while, you take a cargo hold 1 trillion units of ore. With that much ore, given the examples above, this could produce that. Given 1 trillion ore, what is the maximum amount of fuel you can produce? Okay, so so let's think about this. Why would it be any different? So let's say I have a lot of ore. There's still basically only one way to get fuel. So why would it not just be why would there be any economies of why would it be different? 13,312 ore per fuel. Like, why is it not just multiplying? That's the part I'm not getting. So let me think about that and see what is going on here. And I don't need this. I need this. And why is this? Did I do something with like virtual? Yeah, there we go. Okay, so let's just say t equals 1 million billion trillion. And t divided by 13312 gives me a very wrong number. Okay, so let's think about why this would be the case. Because, so what do? I say, like, I have to get 7 A's and 1 E, so I have to get 1 fuel. After hitting ore for a while, you have 1 trillion units of ore. With that much ore, given the units above, the 1332 ore per fuel example could produce that. Okay, so what's the most fuel I can produce? So um, obviously I can't brute force this because 1 trillion is too big a number. I'm just trying to understand why with that much ore, given the examples above, this could produce that much fuel. And It's because I have extras of things, and I can use those extras wisely, I guess. Um, so basically, so if I have that much, I can use anything where 10, like I get, like let's say I have 100 ore, I can use it to produce 100 A's or 90 A's plus 10 B's or 80 A's plus um, 20 B's and so on. So I have all those choices. And then given those choices, uh, given those choices, I can do, I can basically apply rules, any rules I want to. And again, this is like my priority queue thing. The problem is with 1 trillion, that priority queue is going to run forever, basically. Um, so there must be, again, some kind of way to work backwards and say that what is the maximum amount of fuel you can produce? Um, and so, one thing I can do is I can say, um, okay, well, let's think about this because this could be interesting. Least or rules, um, and let's say quantity needed, which is an int equals 1, and or needed, let me just call it, let's say fuel needed, um, or needed equals 0, and requirements equals fuel needed. So, um, so I want to work backwards again, and now I need some sort of weird stopping point where what I can do is I can say, um, rules on d14.py and least or rules 1, 31, 2, 62, 3, 93, 10, 290, 100, 1,000, 10,000, 1,004, 1,005. So for I in range 100, print I least or rules I. And so 31, 93, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5. Is it really just 31 more each time? Um, so like um, could produce this. Um, so least or rules, comma, that is, it says it's 2403, which seems very wrong. Um, it says the 13312. Oh, but that's sorry, that's a wrong um, issue. That's not 13312. 157, that's the 13312. and that's raw 2. So let me say uh, uh, seriously? Uh, so now least or rules 2, and if I do 4, that's more than 1 trillion, right? And so, yes. Okay, so now what I want to do is I want to um, basically just say least or rules 100. Okay, so let's do this. We'll do like a binary search. Um, def find find 1t, let's say, which is, or let's just say find um, find required or for rules, which is a list of rule, and for fuel, which is an int, and that's going to return an int as well. Actually, no, we already have that. So what we want to do is we want to um, find max fuel. Find max fuel rules this and or, which is an int, right? And so let's say or um, least or rules comma t bigger than t is true. So let's say low equals 1, high equals let's say uh, let's say low equals 1, high equals none, and so let's say while I'm just gonna do this by hand. I'm feeling lazy. Uh, least or is less than t. Okay, so it's got to be between this and this. So let's say 500. Nope. 250. True. Okay. Okay. So let's just I'm just going to write this out by hand and not worry about it. Okay, so that's too much. And let's say high equals this. Um, uh, okay, is that right? Yep. Okay. Um, and let's just say t equals 1 million, thousand, million, billion, trillion. Okay, and so while low is less than high, and let's say or low equals least or low, or high equals least or high, and while low is less than high, if or low is less than 1 trillion, so we can do more. Mid, and let's say mid equals low plus high divided by 2. Um, and let's say or mid equals least or mid, right? So uh, if or mid is less than t, so that means that we can still do that much. Let's say low or low equals mid or mid. And let's say less than or equal to t. Otherwise high or high equals mid or mid, and then we keep going. And so now let's run it and see what happens. Int object is not iterable. Okay, so why is that? Rules comma mid. Gotta use the rules. Okay, so we'll just do a good old-fashioned binary search. And that's not working. Print low. There's probably something bad here. Print low, mid, high. Print or low, or mid, or high. And now let's run it again. And okay, well anyway, that it didn't stop right, but it looks like if I do this, and let's say least or rules, and that is less than t, and least or this. Okay, so that means that this I can't make, but this I can make. So let's copy it. 2876992. That is the right answer. One gold star closer to rescuing Santa. Okay, so the key idea here was that it's fast to find out how much ore I need to make, what's the least ore I can to make a certain amount. So if I just use binary search, I just try and make different amounts until I get narrow in on what exactly I can make. So that, yeah. So anyway, that took longer than I thought. Okay. Anyway, it's done. So that's good. And I will see you maybe tonight if I have the energy to do it tonight. Cool.